Hi, so today we'll be presenting on message queues, specifically AWS's simple query service in the context of cloud and cloud development. Before we go into the content, as this is purely virtual, first we'd like to introduce ourselves. Our team consists Marc Hillocks, Ismaeel Hosein, and myself, Aadidev Sooknanan, all of which are in the second year of the MSc in the Data Science program. So, firstly, let's define what a message queue is. A message queue is some form of asynchronous service-to-service communication used in both serverless and microservice architectures. The concept of a queue is messages being stored until they are processed and deleted, right? So a requester or producer might place a message in the message queue, and workers or responders will consume the message placed in the message queue. This provides some sort of lightweight buffer which temporarily stores messages and endpoints that allow software components to connect to the queue in order to send and receive messages. This is usually a small item such as a request, a reply, an error message, etc. So as shown in the image here, a producer would add a message to the queue and a consumer retrieves it. This goes along with the idea of cloud architecture being broken into modular, easy to use building block type, and these are typically easier to develop, deploy, and maintain. So we have a few use cases for message queues. Message queues can be used to integrate on-premise backend systems with the cloud by enabling a decoupled cloud-based architecture. This allows cloud-based applications to communicate with each other or with on-premise systems. Queues increase and improve architectural resilience. It's typically used in scenarios where high levels of security is needed, high levels of fault tolerance, and high levels of accuracy, as shown here, for example, in the cases of airline booking or healthcare records. Queues enable applications residing in different clouds to communicate regardless of physical location. Each system is decoupled, meaning failure for one of the systems is not able to affect the other one. This maintains the idea of separation of concerns in the field of software engineering. This might be one of the more simple ways by which a queue is architected in the cloud, where you have a requester sending a notification to responders, hey, there's something in the queue, and the queue containing the actual content for the responders to act upon. This is an example of a very user-facing queue. This is a NASA image and video library. This provides access to more than 140,000 still images, audio recordings, and videos documenting NASA's achievements. We did a bit of digging and research and found out that the way that this is architected uses AWS's simple queue service. This is a bit of the general architecture behind that service, where Amazon EC2 provides secure resizable compute in the cloud, which allows NASA's service to scale up and down. ELB distributes incoming traffic across multiple EC2 instances for the purposes of redundancy and fault tolerance, etc. S3, their data lake, is used for object storage. RDS is used for synchronization and failover. Dynamo database is used for tracking incoming jobs, published assets, etc. And Cloud Search is used for actually searching these text fields. SQS decouples incoming jobs from these pipeline processes and acts as a sort of a messenger between these cloud processes and architectures.
Dave for explaining what a message queue is. And now I will go into a little bit more deeper detail into what the Amazon Simple Queue service does. And then I will hand you over to Mark, who will do the demonstration for today. So the Amazon Simple Queue service, as Aadidev would have mentioned, is a message queue which takes the messages from the producer and stores it in the queue until the consumer can then receive it. So how the consumer receives it is that they pull the message queue in order to see if there are any messages there. If there is a message, depending on the type of pooling, it returns the results, and the consumer can then go through the messages, and once they are finished with it, they can delete it. And this is how the message queue is used. Aadidev went through a couple use cases for the general message queue and the Amazon SQS. And just to reiterate, they use the message queues for the integration of on-premise systems to cloud, and it decouples the cloud-based application to communicate with each other or the on-premise systems, as well as if the application architecture requires high security or fault tolerance. So now we will move on to how the Amazon SQS scales. This is done through AWS, and it's an automatic feature that scales the queue data partitions depending on the current request rates versus the request rates that the queue can support currently. So, for example, if the queue can support, let's say, 5, and the current request rate is much higher than that, then AWS will then adjust the data partitions to increase it and allow it to support the existing request rates. And this is also alternatively done if it's been underutilized and adjusted to lower it. So now that we went through how the queue scales, we can go through some of the type of poolings that AWS offers for the SQS. And this is mainly the short pooling and long pooling, where in a short pooling, you receive the queries for a subset of servers to find a message, and the available messages is searched for, and the response is sent right away, even though the response may not receive a message. Whereas the long pooling, it queries all of the servers and sends a response only after collecting at least one available message, up to the maximum specified in the request. Right, so this reduces the amount of empty or false responses that you get. There is also a feature which allows you to delay queue, which postpones the delivery of the messages, and it can be up to 0 to 20 seconds, and it reduces the amount of times you have to pull for the message, as it allows, while in delay state, it allows for the picking up of all the messages that comes in at that time. Now we will move into the types of queue in terms of the options available for us when setting up an SQS. This is the standard queue and the FIFO queue, which is for the first in, first out. The main differences between these is that the standard queue has a high throughput with the best effort ordering, whereas the FIFO gives you the order of the first in be the one that be the first out with a limited throughput. And the FIFO also has exactly once processing, whereas the standard queue can occasionally give you a copy of the messages because it does it at least once. The standard queue is used to decouple live user requests from intensive background work and lets the user upload media when resizing or encoding, and it's done in batch messaging and can be scheduled for multiple entries to be added to the database. The FIFO ensures that the user executed commands, the user entered commands are executed in the right order and displayed the correct modifications in the right order. So now I will pass you on to Marc, who will go through the demonstration of the SQS and how we create the message queue, send the message, receive the message, and delete the message, and then delete the queue itself. So thank you for your time, and I'll pass you over to Marc.
Let me start by saying thank you to Aadidev and Ismaeel for their assistance in laying the foundation for this demonstration. Now we will learn how to set up asynchronous messaging with Amazon Simple Queue Service, aka Amazon SQS. We will use the Amazon SQS console to complete 4 tasks. 1. Create and configure a message queue. 2. Send a message. 3. Receive a message and delete that message. 4. Delete the queue. So, as we sign into our AWS account, we will be greeted by the general AWS Management Console. We would now want to search for the queue service by simply typing in queue in the search bar. We see the first result here is going to be the Simple Queue Service. This would now take us to the Amazon SQS console. As stated by my team, a queue is a reliable, highly scalable buffer that stores messages as they travel between distributed applications or microservices. Now we begin our first task. Here I'm seeing that we have a few existing queues from previous cohorts, but we are on a mission to create our own. What do you suggest as a scenario we can apply for this queue we're about to create? How about a queue that will store the incoming orders for a restaurant's kitchen? So, using that scenario, we go about creating our queue. Firstly, we want to select the type of queue we're going to create, whether it be standard or FIFO, which would stand for first in, first out. Based on the scenario, I think we would want to go with a FIFO queue, simply because we believe orders should be attended to on a first come, first served basis, right? Now we'll put in the name of the queue and let's call it kitchen orders. Note, when creating a FIFO queue, the name of the queue must end with .FIFO. As we scroll down to the configuration section, we notice it is pre-filled with default values that are suitable for basic queue operation. We have the ability to configure the following values in order to customize our queue. So first we have our visibility timeout. This is the length of time that a message received from a queue by one consumer will not be visible to other message consumers. It is currently set at 30 seconds and I think that this is a reasonable time, so we'll stick with this. Next up, we have the message retention period. This is the amount of time that Amazon SQS retains a message that does not get deleted. Amazon SQS automatically deletes messages that have been in a queue for more than the maximum message retention period. The default retention period seen here is as 4 days. The retention period has a range of 60 seconds to 14 days. Given the nature of our scenario, I think it would be appropriate to retain messages for no more than 1 day. Next, we have the delivery delay, which is based on the amount of time to delay the first delivery of each message added to this queue. If needed, this allows consumers additional time to process messages. We can delay each new message coming into the queue. Again, for this scenario, I don't think this will be applicable, so we'll leave it at a default value of 0. Then we have our maximum message size, which, as the name gives you essentially, it's kind of intuitive there. This is the maximum message size that you could have, and the default is already given as the max of 256. If we want to send messages larger than 256, we would have to use the Amazon SQS Extended Client Library for Java. This library would then allow us to send an Amazon SQS message that contains a reference to a message payload in Amazon S3. We are also allowed to configure the receive message wait time. This is the maximum amount of time that polling will wait for messages to become available. To become available to receive. The minimum value is 0 seconds and the maximum value is 20 seconds. If we leave the value at 0, this would automatically enable short polling, whereas any other time sets it as long polling. What is the difference? Well, with short polling, the receive message request queries only a subset of servers based on a weighted random distribution to find messages that are available to include in the response. Amazon SQS sends the response right away, even if the query found no messages. On the other hand, with long polling, the receive message request queries all of the servers for messages. Amazon SQS sends a response after it collects at least one available message, up to the maximum number of messages specified in the request. Amazon SQS sends an empty response only if the polling wait time expires. I think we will set this to the maximum, 20 seconds, to employ the long polling. And long polling has the benefit of reducing costs of the Amazon SQS by eliminating the number of empty responses and false empty responses. Next, we have our content-based deduplication. Firstly, deduplication refers to the removal of duplicate messages. With content-based deduplication, Amazon SQS can automatically create deduplication IDs based on the body of the message. In the context of our scenario, based on my understanding, we will leave this unchecked because there are times when we can have similar orders that are placed within a short space of time, and we would not want to risk one of these orders being deleted. Next, we have the option to enable high throughput FIFO. This feature provides higher transactions per second for messages in FIFO queues. If we enable this feature, you can see that it would not allow us to change the duplication scope, nor the FIFO throughput limit. So it kind of just automatically sets those other values for us. And if we enable it, we will see the duplication scope being message group and the FIFO throughput limit being per message group ID. I'm going to go ahead and leave this enabled. We are now finished with the configuration section and on to the access policy section. This defines the accounts, the users and roles that can access this queue and the actions that are allowed. We can configure basic and advanced settings. In the basic settings, we can configure who can send messages to the queue and who can receive messages from the queue. The read-only JSON panel displays the resulting access policy for the following queue. By default, only the queue owner can send and receive messages. In the advanced settings, you can modify the JSON access policy directly. This allows you to specify a custom set of actions that each principal, which is the account, the user, or the role, can perform. At this time, I'm going to leave all the default selections. Lastly, we have a few optional sections including encryption, dead letter queue, and tags. I'm not going to make any changes to any of these sections, but we can briefly discuss them to see what they refer to. When we enable the server-side encryption, Amazon SQS encrypts all messages that are sent to this queue. The messages are stored in an encrypted form, and Amazon SQS decrypts a message only when it is sent to an authorized consumer. With the dead letter queue, this allows you to isolate problematic messages to determine why they are failing. If a message can't be consumed successfully, you can send it to a dead letter queue. Now, like many other tutorials we have gone through, we can also enable tags, which allows us to organize and identify our queues. This is especially useful when we have many queues. With that in mind, I can simply click create and we'll have our queue created. This ends our first task. We move on to our second task. Now that we have created our queue, it is ready to receive messages for orders for the kitchen that can capture the details of each new order. However, let's go back to the list of queues and start from there. So now we are at the list of queues. We can simply select the queue that we want to send the message to. We click send and receive message, and we have our content that needs to be filled. We have the message body, the message group ID, and the message deduplication ID. For this order, let's just put in a sample order, and let's say we have an order for 1 chicken Alfredo, 1 cheese burger with bacon, and 1 portion of buffalo wings. In a FIFO queue, the message group ID specifies that a message belongs to a specific message group. Messages that belong to the same message group are always processed in a strict order relative to that message group. However, messages that belong to different message groups might be processed out of order. We would simply call this group food. Also in a FIFO queue, the message deduplication ID is used for deduplication of sent messages. If a message with a particular message deduplication ID is sent successfully, any messages sent with the same message deduplication ID are accepted successfully, but aren't delivered during the 5-minute deduplication interval. For this ID, we would use 001. 0001. Note, had we used a standard queue, we would not have had these additional IDs to input. And we can also select the message attributes tab to add some optional metadata about this message for easy processing, but at this time we would choose not to add any metadata. Alright, so we can end this task by simply clicking send message. And we have our green banner telling us that the message has been sent. This ends our second task. Now we begin our third task, which, if you remember correctly, would be our task to retrieve and delete the message that has been sent. So as you see here, we can actually just scroll down and receive the message at the same, in almost the same space. I would prefer to go back to the list of queues and let's start from there. So to get back to where we were, we're going to select the queue we're looking at, which is the kitchen order queue, send and receive messages, and we're now back to the receive messages area. Notice we can have a message, we see a message available, but no message is listed. In order for us to see the message listed, we will have to poll for the message. Before we do that, let's look at the poll settings that are currently in place. Polling would take place for 30 seconds, and we would retrieve a maximum of 10 messages at one given time. This is quite appropriate, so we'll leave this and we'll poll for messages. We see it's listed one time. We can click to view it. This is the order we just placed. We're done with that. And we can just delete it by highlighting it and clicking delete. There we have our message retrieved and deleted successfully, and this ends task 3. So all that is left for us to do now is task 4, which is to delete the queue. And we can do that by just going back to our list of queues, and we remember we saw a bunch of other queues. Now, it's always recommended once the queue is no longer needed, we should clean up after ourselves essentially. So we're going to go ahead and delete our queue and the other queues that were there before. To do this, we're simply going to highlight the queue and click delete. We would then be prompted to type the word delete to ensure that we want to delete it, and then sign off by clicking delete. And as we're going to just repeat this process for all of the queues here. And last but not least, and we are done. So we have just completed our final task, which ends our tutorial for today. Thank you for your time and your attention.